Hello everyone and welcome to another Würth Elektronik ISOS webinar. My name is Markus Eberle and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar. The topic of today's webinar is Component Selection with RedExpert, Basic Level. Our speaker today is Ina Franjic, who is working as Product Definition Engineer at Würth Elektronik ISOS. She will hold today's webinar and also answer your questions. As we also take all possible steps against the coronavirus, we are unfortunately not sitting in the same rooms today, but are holding the webinar out of the home office. In case of technical problems, please take this into account. We will do our best to make a smooth process possible. Before we start the presentation, I would like to point out one thing. You will be muted during the webinar today. This means that you cannot ask us questions via microphone during the webinar. Nevertheless, you have the opportunity to ask us questions during the webinar at any time via the chat function. You will find the chat function in the webinar control panel. The webinar will be about 30 minutes long. The chat questions will then be answered in a question-answer session following the webinar. There are 10 to 15 minutes in addition scheduled for this. If we are unable to answer all your questions within this time, we will answer them via email after the webinar. If you still have any other questions left after the webinar, just email us at isos-webinar@we-online.com. We will try to answer all questions promptly. At the end of the webinar, you will be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve our webinars. You will receive the link to the presentation as well as to the recording of the webinar only in the next few weeks, as we need a little longer processing time due to the extended webinar offer. So now I will hand over to our speaker, Ina, and I wish you an exciting webinar.
So hello everyone, my name is Ina Franic. I'm really happy to see you in such a big number or to hear you. Today I will talk about RedExpert, our tool, and what is the best and easiest way and the quickest way to pick components for your application. So agenda is as follows. First, I will give you a short overview and the range of functions of RedExpert. Then I will show you a few applications for RG45 transformers, for ceramic capacitors or MLCCs. What is the easiest way to pick up the best component for your filter applications? I will say something about SMD ferrites, and for the end I will talk about inductors. So now I will switch to RedExpert tool. I think the best is to show you how it looks, how it works. So this is the sign-in screen when you open it. You can find on our website. Here you can log in, register, or continue without login. What we say that registration is not necessary. All the options are still available, even if you don't have a user account. But if you get a user account, your benefits will be that you can get free samples directly from RedExpert. If you need higher quantities, you can request quotation. You can use sliders. I will talk a little bit about them a little bit later. And also you can have all the displays in the table. You can also compare more components. And also very important thing is once you register, your email address will not be used for any advertising purposes, only to confirm of the samples or your order or inquiries. So now I will log in and we can start. My computer is not working today properly, obviously. So yeah, this is a short overview of how it looks once you log in. You will have fast and easy component selection. You can switch in other tools, so EMI filter design tools, power stage design tool, wireless connectivity, magic power module, and you can switch between LEDs. Once you go into fast and easy component selection, you will have a really nice overview of our portfolio. So you can pick between EMC components, power products, so from inductors to transformers. Then we can go to signal communications. We have RG45 transformers, RF inductors. Then you can choose from a variety of our capacitors. And also you can choose LED from our optoelectronic portfolio. So first I will tell you, for example, how you can choose RG45 transformer. So if you ever needed a transformer, you know that it can really be a tough decision. There are a lot of parameters you need to pick from. What is the speed? How many ports you have? Is it PoE or not PoE? How is mounted, THD or SMT? What is temperature range? So it's really easy to get lost, especially if you're using catalog. That's why it's super to use RedExpert, because you can quickly find the proper component. You can filter them. So for example, you can use this funnel sign, and then you can say, okay, I need only a transformer for 1 gigabit per second. You press continue, and this is it's going to be all possible solutions for this speed. Then what you can filter further is what kind of mount is it, what is temperature range. Also you can do by size. Do you need LED or don't? So as I already said, this is really fast way to pick a transformer. You can see here we also have schematic. We can have mechanical dimensions, and also for a component with so many pins, we also have a recommended solder pad. Then also another component that is used on every design, every board, are MLCCs. Although they are really tiny, they can also cause a lot of headache sometimes. And also there are not so many tools for a pick of MLCCs. So that's why RedExpert is really helpful, because you have an overview of impedance over frequency, ESR, capacitance change or DC bias, and how capacitance change with temperature. So we have the table here. We can compare multiple components with it, and also we can see what is, for example, how two components behave and how is their DC bias behaving. So now I will switch back to presentation. So this is one example of comparison of three kind of capacitors. As you can see, they're all the same capacitance value, so 100 nanofarads. But the only difference is that one is 2R0402 and one is 0603. And here you can see that, okay, it's maybe different size, voltage is similar. What is the big difference, and what can be, what needs to be taken care of? For example, here you can see that DC bias is really big difference between three of them. Impedance is similar. So this is why it's very important to always double check the ESR and DC bias, because sometimes you can want to do downsizing and you see datasheet, and in datasheet everything, the capacitors look exactly the same. So we have example here. So we have size 0805, another one is size 0402. We see that they are both 100 nanofarads, 16 volts. Great, you see this data sheet, you think, oh my God, I can use the smaller one. I will have I will save some space on my PCB, and everything will work great. But of course, life is not that easy. So because we cannot see DC bias in the datasheet, we need to have double check. And when we do a double check for these two capacitors, we see a really big difference. So the properties are no longer the same. With a smaller size, the DC bias, or DC bias is the loss of capacity under voltage, has a really bigger impact. So this is the orange one. As you can see on the graph, the DC bias will be much higher. So downsizing is not possible every time, and we also need to have this always in our mind. So you always need to take care of all components, and that's why RedExpert is really helpful, because you can compare them directly, and then you can be for sure 100% sure, okay, this I can go downsizing, this I cannot do. This is more comparison of different MLCCs. What we can see here are sizes from 100 picofarad to 1 microfarad. This is a comparison of characteristic curves. We have example of 1 microfarad one. This is like the highest capacitance, but the highest capacitance mean the lowest impedance. So this kind of capacitor is ideal for EMC filters when capacitor is used for short circuit. Only so we have this low impedance. It only applies up to resonant point, and after that it goes up again. So also we need to see that this kind of capacitors cannot be used for higher frequencies. So this is also something we need to take care of. So you need to use smaller capacitance if you need application on higher frequencies. So now I'll go back to RedExpert and can talk a little bit about filtering. RedExpert, he takes over the calculation of the impedance, and he searches for the best solution for your application, depending on what is attenuation that you will need. So when we have example of one system and we need to put in the parameters, it depends on many things. So we always have the source impedance, the impedance of at a particular frequency, and the load impedance. So in this case, it's not always easy to find what is the right impedance or to know the impedance. So we always have some kind of assumptions that for the source impedance, we can say, okay, is it ground plane? Is it supply voltage line? Is it some kind of data signal, or some kind of long and very high speed data signal? And according to this, we can pick the right one, and then we can see what is the attenuation that we will need, the frequency, what is the bias current, and after we put all the parameters, we can press display details, and the program will give us what are possible solutions. So because we have really, let's say, case that fits a lot of applications, we have also more than 277 possible items. So in this case, we can, for example, compare this one. Also, we can filter them additionally to see if, for example, you might not need the size that you will need, or what is current, what is RDC. So this is all parameters you can filter additionally, of course, after you type in all the needed information. So yeah, so additional thing we have is this slider. So you can move it. Depending, you can add also additional sliders or remove them. And also you can filter additionally for what kind of so when you put slider on which, for example, which attenuation should, impedance attenuation should be shown at what frequency. So this is additional thing you can play with. Now I will go back to slides to talk more about the definition. As I mentioned, this is also in the RedExpert implemented. We have the source impedance, VA. Then we have impedance of the ferrite at a particular frequency, and the load impedance. So in this case, we have a formula that is for attenuation. So for system attenuation is the one that is the middle one, and the needed impedance for this attenuation is this formula, second one. So, but now we have problem because we also have a lot of unknowns. So we can assume what will be the source impedance or load, but it's never something that we can say 100% unless we measure. So as already mentioned, it is also depending what can we use for, let's say, from our experience. So for ground plane is 1 ohm, for power supply 10, for clock and data lines 50 to 90, and for long data lines 90 to 150. Also, one possibility to pick the best, to choose the best ferrite is Nomogram. This is, you do your EMI test. You see that you will need attenuation of 20 decibels. And let's say this will be the power line. And then you can go this 20, 20, 20. You see it's meeting here. So here we can say we need around 110 ohm of impedance of the for the attenuation of 20 decibels on this line. So this can also be very helpful and very quick solution, or you can or use RedExpert, who will also do this to you and already recommend you what are possible ferrites for this application. So yeah, this is what I already mentioned. So yeah, this is it will be automatically shown RedExpert, and you can filter them additionally by size, RDC, rated current, if it needs to be ICQ200 or not, what kind of is it SMD or THC technology. So this is something that it's really easy to use and a really helpful tool. So slider is also something that I show you already. You can use it to additional filtering. To filter between a certain frequency range. So what will be the best possible solutions? What kind of ferrite will be the best for this application? Also, depending on which slider is chosen, the data for this slider will be shown in the table, and this you can see by this sign. So as once you pick the one, you always need to take care that you need to take care that resonance frequency is good, so that it's not before your working frequency. That you need to check additionally nominal currents. So all this part. So don't use RedExpert. Okay, he gave me this. Now I will use this. Always check additional parameters for the best performance of your application. So one example for this is the Como choke for data line. So we can see that this is practically the similar choke, but here we can see that comparing the characteristic curve, even though their impedance is the same, they won't perform the same because the yellow one has self-resonant frequency around 2 megahertz, and the blue one has around 40 megahertz. So this is really big difference. So I mentioned if you just check the data sheet, they look similar. So always double check the the graphs, always compare them if you can, because this will give you the best solution. So yeah, what is important that also for picking, we need to pick the current, what is the current needed, and this we can do on the system tool, and you can type in the bias current, and then you can see what kind of farads will be proposed for this application. Why is this important? Well, in one small case, we have a simple circuit, we have inductor, we have capacitors. So we have capacitor that has ESR around 200 milliohms, and then we have a RDC of this ferrite around 150 milliohms. So this is altogether 350 milliohms of inductance we have in the circle. When we divide, so input voltage that is around 12 volts, with this, we have a current of 36 amps. So as you can see, that is really, really high current for a very, very small time, but this current will be enough to destroy your SMD ferrite. And not all of them can withstand this current. So this is why it's important to type in the current to see and to check what is the best solution, so that you're sure that you have a ferrite that will withstand it in case you have some overcurrent or you have this really, really high peak when you after switching. Then for the last one, I will tell you something more about selection of inductors. So we can choose the inductor according to application. So depending on what kind of converter you have, you can type in the parameters of your buck, boost, and step-up converter. And once you do this, you will have another window where you type in the input-output voltage, output current, switching frequency, ripple factor in percentage, and what is the voltage of diode. So in RedExpert, it's not only showing the possible inductors for the switching power supply, but also calculates the losses. And this is also AC and DC losses, and their combined will give you total losses. Here we have one example. This is IC from Texas Instruments. This is IC we use in our PMLK kit. This is a really good kit in which you can check how different inductors perform and different switching frequency. You can really play with it. So if you have interested in it, you can check more on our website. So for minimum inductor for this IC, we have a formula, and this is formula that Texas Instruments recommends. Now we will compare this formula with our RedExpert result. We type in all the technical data, so in RedExpert, and this is what we got here. So what you can notice is that so just display date that the inductance that was calculated by RedExpert and the one that was calculated by the Texas Instruments formula are a little bit different. So why is that? That happens because TI, they didn't take in account the voltage of diode. But since there is if there is a big difference between output voltage and the diode voltage, then the diode voltage can be neglected. So we don't need to use it. And as you can see in previous case, the value was around 15 microhenries. So this is good enough. And also, if you're having a design and you get this, let's say, optimal inductance, it's also sometimes good to play with some values a little bit above and under it to see what will be the perfect fit for application. So yeah, this is the case I showed you now. So it also, as you can see, the optimum is 15.6 microhenry. But if you check in the table, you can see that you have 15, 12, and also some additional values. So it will also include some, let's say, we will have the range between different type of inductance values, so you can pick the best solution. Also, what I already mentioned is that RedExpert will calculate the losses. I will tell a little bit more later about how exactly those losses are calculated. But you have the AC losses, DC losses, what are the total, and also you have the total temperature raise. Okay, and now the question is how the AC losses are calculated. So we use the Steinman's approach, the Steinman's formula. What is special about this? That this formula includes what is frequency in kilohertz, what is magnetic flux density, and the additional parameters K, B, and A. Those are called Simens coefficients, and they are found by material BH curve, and they vary with temperature. So this formula you're already probably familiar with or heard about it during your studies. And here on graph, you can see how it changes depending on what is the frequency. What is, let's say, drawback for Simens formula is that it can only be used to a limited extent for real inductors. So it is good for testing materials, but when you have a real inductor, you also have a core, you will have other different things. So it's not 100% correct. And as you can see on this graph, it is the most accuracy it has at 50% of the duty cycle. That's why we in Würth Elektronik and also for implementation for RedExpert, we use the modified Simens relationship, and also we have a measuring device for all inductors to find out what are let's say the best and the most accurate AC and DC loss calculations. As I mentioned, we use a special measuring device, so we have buck converter and Class D amplifier. There we can see more variable parameters, and we find the losses by measurements. So we have the operating point, we find a triangle sinus wave. Also on the following graph, you can see why it's different, why the pure Simens formula is not working for inductors, because it only shows core losses, and it works with sinusoidal excitation. And for RedExpert, we take in account working point and what are the total losses. So here you can see which points of pH curves are taken into account, and there you can see that a certain working point, why our approach is much more accurate. So for the losses, you can see the graph of so how it looks and how accurate it is compared to Simens formula. For Simens formula, it was the most accurate at 50% duty cycle, and with our model, we have really high accuracy for the whole duty cycle. So what we take into consideration is core geometry. We also take account stray field defects on air gap, what kind of material mixtures we have, what is the winding structure, and what are the AC losses in the wire also, not only in the core. So also what is very important is when you're picking inductor to take care of saturation, because if you go below saturation point, you will have a big fall of inductance, and that's not good. Also, according to your application, it's good to take care if it's soft or hard saturation. So for this example, we need to take them in account when we finding the best inductor for our application. The one, let's say, bad thing about saturation current is that it's not standardized. So it's also good to check in datasheet from us for other producers what percentage they take for saturation current, what is the, because they can use that inductance drop of 10% to 35%. So of course, somebody who uses higher percentage is going to have lower saturation current than somebody who is using the lower percentage. So this is also something that you should double check. And also RedExpert, you can check what is operating point with slider. You can also compare them, find the best solution for, let's say, for this current, what inductance you will need. But I will hold another webinar in May about inductors. So there will be I will talk much more about saturation and inductors altogether. So if you will find this interesting, I will also invite you for this webinar because it's going to be mostly focused on magnetics. So yeah, thank you for your attention. This was all for me for this afternoon. Now, if you have any questions, feel free to ask, and Marcus can talk now. Thank you very much.
So yeah, thank you, Ina, for this great webinar and this interesting presentation about the RedExpert. As you mentioned, now we would like to turn our attention to your questions, and we wait a little until some questions come in. To ask us questions, you have the opportunity to ask them via the chat function. You will find it on the right with the webinar control panel. So yeah, Ina, the first question arrived. How many components can be compared to each other at the same time?
Well, last time I tested, it was around, I think it was 16 components. So for now, it's 16 components that you can compare, because then I think it makes sense, because if you have more than this, you're going to have just a big mixture of colors, and visibility will be very, very bad.
Okay, but that's a lot.
Yeah, definitely, it's a lot. So you can really go into every detail. You can use slider to go even more detailed. Then also when you use slider, another table will show up. So maybe you can find some additional inductor or TB ferrite or convol choke you might use. So yeah, it's fun tool to play with and to test all the possibilities.
Okay, Ina, thank you for the explanation. Now we look for another question. So Ina, the next question, which topologies are available to choose from for inductor selection?
So you can, we have 3 different topologies. So buck, boost, they can all be synchronous, non-synchronous, and also you can use SEPIC, and also we have the one separate window for only 4 losses.
Okay. Then the next question, Ina, how can I get samples after selecting inductor?
So this is you need to be registered first, because we need to know to whom are we sending them. But once you picked the inductors, there is one, let's say, like a shopping cart which you can click, and then you will have the possibility to add to your items, and that will be, then you have the process to send it, and somebody from our online marketing will contact you, and from our sales, and send you the samples.
Okay. So now we have a look at the other questions. And yeah, Ina, there's the next one. First, thanks for the webinar. Can we use the graphs for reports, so for client consulting?
Yeah, of course. You can also, you have a button for when you pick up configuration, so you can filter already. You can pick which graphs you want to send, and then you have the share button, which you can press, and it will, you can send it directly with email to someone you want to send, or you can just easily copy the hyperlink, paste it to someone you're sending the they want to send the results, and when they open it, they will have exactly your what you search for, all the filters, everything will be visible for them.
Okay. So thank you for the explanation. Now we will have a look at the next questions. So Ina, next question. In case of buck converter, can we select any component other than inductor? For example, can we choose an output capacitor?
Unfortunately, for now, not yet. But this is something I think we'll work on future because it will be also, I know, very good feature. We need to see with our team responsible for RedExpert what are the features that will come in the future. But this is also some very, very interesting thing, and it will be very, very helpful. So for now, not yet, but in the future, who knows? I will give them definitely the feedback so they know that this is something that is sought for.
Mm-hmm. Okay. So Ina, the next question has arrived. How can I check the stock status using RedExpert? Is that possible?
No, so you cannot check the stock, but usually for samples, it's not a big problem to get them out of the stock. But once you made a request, somebody will contact you in case if components are not on stock or something, and then they will tell you what are the lead times. Also, they can maybe recommend you some other component. But you, as a like a person out of this company, you cannot check the stock status.
Okay. Yeah, but therefore you always can get in touch with us.
Yeah.
So we have a look at the next question. Ina, is there a plan to check rough price level for the component in RedExpert?
So I don't know if there is a plan, but for now it's not possible. So we will need to see also in the future because our prices are mostly defined by our sales team. It also depends on the quantities you are going to take. So let's say rough prices for now don't exist. We need to see for the future what will be within the possibility, but it's a great question and it is a great feedback to give to our team. Maybe they will think about it, or maybe they will come to some kind of solution for this thing.
Okay, thank you for the explanation. So if there are questions left, we will answer them. We have a look at the other questions. So Ina, the next question. How can you be sure that your approach gives more precise value than the Steinmetz formula?
Well, we did testing, and this is what it came, because also Simens formula only measures the what is the material, but as I already mentioned, depending on inductor is not only the core material, we also have the air gap, winding structure. There are different material mixtures. We have additional AC losses in the wire. Depends on core geometry. So yeah, with a lot of tests, a lot of calculations, we find out it is much more accurate, and of course also for the whole duty cycle.
Okay. So we will wait a little bit until the next question arrived. Just a little hint, if there is an open question until yet, we will answer them via email after the webinar. So, but Ina, the next question arrived. Can RedExpert also provide the hysteresis curve for the coil?
No, we don't have this feature, unfortunately.
Okay. And Ina, now the next question also did arrived. Where can we announce dead links? Some links to PDF files are dead. So is that possible? Is there something like a support?
Yes, when you open RedExpert, you have also in the lower right corner, but I don't know if it's only for Germany for now, like a chat where you can also, when there's someone from our sales, and then you can tell them, but there should also be email where some kind of support where you can so tell to them that this link doesn't work, and that will help you.
Okay. Ina, thank you for this explanation. We have a look at the questions. So Ina, the next question. Do you have any offline tool like the RedExpert?
We don't have official offline tool like RedExpert, but what you can do is that when you online, you can go to RedExpert under your after you log in, after your name, you can click it and you can download offline modules. So this is something that when you know you're going to go maybe to some customer, or maybe you don't have a good internet connection in your lab, you can preload them, let's say, and then you can use it later offline without any problem.
Okay. So we see there are not any other questions yet. We wait a little until maybe a new question arrived. And there is the next. Ina, is there any licensing required to download RedExpert?
No, there is no licensing required because you don't download it. You just open it in your web browser, and that's it. So you don't need to download anything, to install anything. So if you can open all other pages on the internet, you can open RedExpert.
Okay. So yeah, Ina, the last question. When will quartz crystals and oscillators appear in RedExpert? Can you say something about this?
Unfortunately, I don't have answer to this question, but I will check with our quartz and oscillator team if they plan to do this, and then I can give this answer to the person who asked for. But for now, I really don't know.
Okay, so thank you, Ina, for this great webinar. And now we are finished with our webinar. If there are any questions left, we will answer them via email. And so thank you very much for your attention, and I hope you enjoyed our webinar. Also, many thanks to you, Ina, for this really great webinar. I hope
Thank
we
you
will
very much.
hear us. I hope you will hear us at our next webinar, and I wish you a good day. Goodbye.